Oh, g'day viewers. So you may recall I did a bit of a DIY project over Christmas of installing a turbo to my Gsx1400, and I did put out a bit of a call out on the Gsx1400 Owners Club and Facey pages, just looking for a little bit of guidance. And they were great, the only people that did really help significantly had done big dollar builds, and that wasn't where I was going with this. I think when I spend a lot of money, it'll be on maybe a Hayabusa, but I just wanted a cheap little Christmas project, and using a clone turbo. It's like a GT25 clone, so it was quite cheap. The turbo was actually the cheapest part of the build. So I ended up making that all happen. I still had a lot of questions about fueling. Like, I obviously knew I was going to run lean. So I did have a Woolwich tuner, so I could pump up the formulas to add more fuel with the standard injectors. But that's probably the last bug I have to iron out now. So with the standard injectors and the map richer in the higher revs, it's still very lean, as you'd expect. I'll just bring the lift down a little bit to show you everything, but I was running an AFR meter there with the wideband sensor, just while I was setting things up, just to see how it's going. And most of the rev range is actually running a little bit rich, which is interesting. But then it may be because of the turbo restrictions with a smaller airbox, not sure, less air, don't know. But then when it come on boost, it was very strong, but it ran out of puff pretty quickly on the drag strip, obviously, because once it was under boost, way lean. So I've only done a couple of runs, because I don't really want to destroy the engine and burn the valves entirely. While I sort out the fueling, I'm just doing it piece by piece, just to try and keep it as cheap as I can. Like I said, I'm sure when I get a bigger, better, faster, stronger bike, that's going to suck up a heap of money. I didn't want to do it to this bike. So as you can see, I just bought the stainless steel header tubes, like straight tubes, and just pie cut that, welded into my own collector onto a T3 adapter plate, onto the turbo, and then just did a 2.5 inch stainless pipe as the exhaust pipe, welded in the wideband sensor bung. I just had some laser cut rings made up that just fit over the exhaust headers, and TIG those in to act as the stoppers for the clamps for those. So that worked quite well. I did my oil supply for the turbo. This is the generic oil line that come with it, just straight off the bung underneath there. It's right next to, I think that's the pressure sense. No, that's the oil temperature sensor. I think the oil pressure's in here. But anyway, it's the same gallery. So you're getting the higher pressure oil that goes off to the turbo. Obviously, I'll take this cover off in a sec, but I've got a welded up airtight air box there that the turbo feeds. Without the airbox, obviously, I just chucked a breather on this case breather and the head breather. That's about it for that side. There is a pressure IAP sensor that goes on the side of the airbox here. That can just get plumbed straight into your new airbox. You have to obviously make a fabricated airtight airbox. That can just go in there. That only affects 0 to 10% of your throttle openings anyway. So when you're on it, it doesn't matter what's going on with that IAP sensor. You can just see here I added a little jump pack thing for the racetrack, because you're starting all the time and not running for very long. Sometimes the volts get a bit low. So as you can see here, got the turbo with the pod. Cheap as chips turbo, but geez, it's done really well. It's not getting hot in the bearing spaces or anything like that, so pretty happy with it. That's that generic oil feed line, obviously a little long. I did put the restrictor in there because as I learnt along the way, being such a low mount turbo, the turbo bearings here are actually lower than the oil line in the sump. So of course, as soon as I started running the bike and testing and tuning, this is basically just free-flowing engine oil out of here and acting like a siphon. So that was a very short learning curve about low mount turbos and what that requires. So obviously you can see under here I've got an oil scavenger pump, and I'll just go around the other side. So the turbo needs an actual gravity drop so that the oil passing through the bearings can collect in like there is a cavity at the bottom of the bearing housing, and that allows that to drain away in a normal environment if this turbo was mounted higher. If I was going to remake these headers, I'd probably make them tighter and try and get the turbo up here. But as I just bought this off the internet and it is far too large to go up here, a more compact little turbo would probably come on boost earlier and fit up here better and be a high mount. But as I mounted this low mount and finished my headers, I wasn't about to change that. And the easy fix, or I found easy enough, was to plumb in a gear pump, and you can just search eBay for those, the oil scavenge turbo low mount oil return pumps, blah blah blah, they're all called the same thing, all basically the same, just get a 12-volt pump. Some run different amps, but I'm pretty sure they're all exactly the same. But and I put in a check valve as well, just for security, because on the drag strip, if you drop any oil, you're out. And I also have an aluminium belly pan that goes under here to try and catch any drips that might occur, just because there's so much plumbing under here. But you don't have to. Like, I did all of this just to protect it, because when I put it on my ute, and sometimes I've been drinking or it's late and I bash the bottom of the bike on the ute, I don't want to damage anything, so I just made up this little thing here. So that's pretty much it for that. Now I'll just take these side covers off so you can see what I've done with the airbox. Oh yeah, with the side covers off, you can see here that I've just welded up a fairly small airtight airbox, and the charge pipe from the turbo goes up into that. So that all works quite well, and just you can use the original airbox to get your spacing and sizing for all of these. Getting the airbox out is a pretty big drama if you want to save it. It's basically engine out job, so it's easier just to cut it with a sip saw and drag it out in pieces. And if you ever want to pull the turbo off, you can just go back to pod filters or something like that, in my opinion. So next thing on the charge line, you'll see I've got the pressure offtake for the boost gauge, it's still on the charge pipe, and then a blow-off valve. So the reason you need a blow-off valve is at full noise, turbo's still spooling, you shut the butterflies in your throttle bodies when you chop the throttle. This is still going to be spooling for some time, a short time, which will create a lot of pressure against those closed butterflies, and it's not good for this system. So this blow-off valve has a couple of preset springs, and the vacuum created by you closing your vacuum and the engine still operating, the vacuum combined with the spill pressure will open this piston, and it'll blow off that excess pressure, protecting the throttle body intake system. Coming down to the turbo, so this is that oil feed line from the other side, comes out the top. And then you'd need to sort of index the housing on the hot side. You'll loosen the bolts and slide it around so that your oil feed and oil drain are vertical, just to give it the best chance to evacuate that bearing space of oil, because there's no actual oil seals as such. It's like piston rings, oil gap. If you don't let it drain out of the well cavity in the bottom of the bearing space, it'll weep through and come through your air filter. It'll come out of the exhaust as well. With these low mount turbos, because the turbo itself is quite high compared to the, quite low compared to the oil line here, oil level of the sump. So it'll just backfeed into that bearing space and just start free flowing out of the exhaust. And it's like with drag racing, you can't put anything on the track or you can't race. So let me have that drain going out that way. So just flip over to the other side. You have your atmospheric pressure, and then you have your IAP pressure. I think it's the IAP, I can't remember now. Pretty sure it is. Anyway, just plumb that. That's usually plumbed into your airbox, this OEM airbox. You can just plumb that straight into here. When you're tuning it, this only accounts for 0 to 10% of your throttle position anyway, so it doesn't really serve any purpose or cause any problems for drag racing as such. And we have our head breather and case breather, and that's pretty much it. So the drag of amperage draw from the pump, the oil scavenge pump, is quite high. So I actually run a second battery under the seat, not hooked up to the charging system, because the stator and regulator, I don't think they like that much current. And I did have a regulator rectifier burn out and failed to charge. I don't think it was very healthy anyway, but it's the load of that oil pump created some spark issues at higher revs, so I ended up just running the second battery setup, and that's a 7-hour start battery that I pop in there, and that lasts the whole race meet, and it doesn't then fight for power from the stator rectifier from the start battery going to the coil, so that sort of simplified things there. So I need to now look at higher flow injectors. So if anybody has any knowledge that can help out of direct replacement injectors for these standard Gsx1400 injectors that go straight in, that are a higher flow, please let me know in the comments, because that obviously is my next step in my quest to do this as cheaply as possible, because the higher cost builds will have a secondary fuel injector rack here with 4 more injectors, but they'll also have injector controller modules, and bringing on those 4 other injectors, and it's starting to get too expensive for what I want to spend on this bike. So I'm just going to go down the route of tuning with larger capacity injectors. So like I said, if you know anything about these and have seen anybody swap them, or know what GSXR ones fit or whatever, let me know, so I'm not buying multiples of ones that don't fit. And then hopefully I can start seeing some richer numbers in my AFR meter. And I'll just take the bike lift down a little. You'll also notice too that I've gone away with the the oil cooler, because I don't really need that for the short runs on the 8-mile track. And I've just put a blocking piece on there. You can see that focus. You can see that aluminium block down there. Just machined that up, just with a simple gallery that goes through it, so the oil can just pass from one side to the other and return to the sump, like or filter as it would if it was hooked up to an oil cooler, just to give me the room for that spaghetti western down there of the exhaust pipes. As you can see here, added a boost gauge, and that's temporary AFR meter, and then of course the switches for the oil pump, because this needs to be running before you start the bike, and then once you turn the bike off, this is still running, then after a few seconds you can turn it off. If you don't do that, oil will dribble out of here, and it'll be very smoky when you start it up. And you know, on the drag track you can't do that, that's bad news. But I definitely would recommend going with a high mount, getting a smaller turbo, make it more compact, even if it meant going further off to the side to give you clearance from the wheel, up here somewhere, so that you could get a high mount. Then you could pretty much do away with that whole scavenge pump installation. Okay, I think that's about it for now, and we'll see maybe what the next chapter brings with the injector update.